according to maximum modulus principle, if f of z is a non-constant analytic function defined on a region omega, then modulus of f of z does not attain maximum on this region omega. Next, we are going to discuss about another form of maximum modulus principle. And if this function f of z is defined and continuous on a closed bounded set E and analytic on the interior of E. F of z is defined and continuous on a closed bounded set E and it is analytic on the interior of E. Then the maximum of modulus of f of z on E is assumed on the boundary of E. Okay. So we need to prove that the maximum of modulus of f of z on E is assumed on the boundary of E. Proof. Here E is a closed bounded set, so it is a compact set in this complex plane, and f of z is a continuous function on E. Therefore, we can say that modulus of f of z has a maximum on E. Since E is compact, modulus of f of z has a maximum on E. Suppose modulus of f of z assumes maximum at z naught in E. If z naught is in the boundary of E, that is if z naught is a boundary point of E, then there is nothing to prove. And if it is lies in the interior of E, if z naught is in the interior of E, here E is a closed and bounded set. So when we consider the interior of E, it will be the union of open connected sets, and each of the open connected set is known as components. So when we consider this point z naught is in the interior of E, so z naught belongs to some component of E, and each of the component is a open set. So z naught belongs to an open set omega naught, or in other words, z naught belongs to a component omega naught of E, and omega naught is an open set, so we can find a neighborhood of z naught such that that neighborhood is contained in omega naught. Also, we can find a neighborhood of z naught such that modulus of f of z naught is the maximum on that neighborhood. Okay, so here we are choosing a neighborhood of z naught such that that neighborhood is contained in omega naught, and modulus of f of z naught is the maximum of modulus of f of z on in that neighborhood. Okay. If z naught is in the interior of E, then if z naught is in the interior of E, then modulus of f of z naught is also the maximum of modulus of f of z in a disk modus z minus z naught less than delta, which is contained in E. Now suppose omega naught is the component of E which contains the neighborhood modus z minus z naught less than delta of z naught. Okay, അതായത് ആ ഒരു നെയ്ബർഹുഡിനെ ഒമേഗ നോട്ട് എന്ന് നെയിം ചെയ്തു. Okay, since f of z is analytic since f of z is analytic on omega naught, here omega naught is contained in the interior of E and f of z is analytic on E. Therefore, f of z is analytic on omega naught. Since f of z is analytic on omega naught and since modulus of f of z assumes maximum at the point z naught in omega naught, we can say that f of z is a constant function on omega naught, because according to previous result we have proved that if f of z is a non-constant analytic function defined on a region omega, then modulus of f of z has no maximum on omega. Here modulus of f of z is analytic on omega naught and at z naught modulus of f of z has a maximum. So the function must be a constant function on this region omega naught. Okay, so this function f of z is a constant function on omega naught, because if f of z is a non-constant analytic function defined on a region omega, then modulus of f of z has no maximum in omega. Okay, so the function f of z is a constant function on the region omega naught. And when we consider a point from the boundary of omega naught, now consider a point set from the boundary of omega naught, then there exists a sequence Zn in omega naught such that Zn converges to Z. Okay, here Z is the boundary of omega naught, so we can find a sequence in omega naught such that sequence converges to Z. Now consider the modulus of f of z, which is equal to modulus of limit n tends to infinity f of Zn, and it is equal to limit n tends to infinity modulus of f of Zn. Here Zn is a sequence in omega naught and f of z is a constant function on omega naught, and also z naught is a point in omega naught. So it is equal to limit n tends to infinity modulus of f of z naught, and it is equal to modulus of f of z naught. That is, for any point set in the boundary of omega naught, modulus of f of z is equal to modulus of f of z naught. And modulus of f of z naught is the maximum value of this modulus function f of z on E. That is, on the set on the region omega naught. Therefore, we can say that modulus of f of z naught is the maximum value of modulus of f of z on the boundary of omega naught. And the boundary of omega naught is contained in the boundary of E. Therefore, we can say that modulus of f of z attains maximum on the boundary of E. Here, z naught is a point in the interior of E such that at z naught modulus of f of z has a maximum. And now we proved that in the boundary of this set E, the modulus value of this function f of z has maximum. Okay. So in any case, function has a maximum at boundary. The modulus value of the function has a maximum value at the boundary of E. Okay.